Welcome to this video, dear learners. This is mathematics. Our topic for today is indices. So let us consider we are given a question, and this question says evaluate. Usually question on indices, they bring them like this: evaluate 3 to the power 3. Okay, so when you have such a question, the first thing you have to do first, okay, this bigger 3 here, okay, it is called the base, and this small 3 here is called the power. Okay, so in other words, when you have a bigger number a and a small number b, okay, what this means that b is the power and a is called the base. Okay, so technically these are what indices are. Okay, technically these are what indices are. So now what does this mean? Okay, so when you've been given 3 raised to the power 3, okay, this simply means that this base, the 3, you're going to multiply it by itself. How many times? 3 times. Okay, so this means that you're going to get 3 by 3 by 3. That is what this means. So this 3 on top tells you that multiply this number by itself 3 times. Okay, if it was like this, 3 squared, okay, this would have been written, so this 2 says that multiply 3 by itself 2 times. Okay, by itself 2 times. Okay, so if let's say you're given 3 to the power 5, this tells you that multiply 3 by itself 5 times. So this is going to be 3 by 3 by 3 by 3 by 3. 1, 2, 3, 4, 5. Okay, so that's the interpretation. Okay, that is the interpretation. So 3 to the power 3, meaning you multiply 3. So when you multiply 3 by 3, here you get 9. Okay, this 9 multiplied by the 3, you get 27. Okay, and when you multiply 3 by 3 here, you simply get what? 9. Okay, and so on and so forth. So technically that's all what indices are all about. Okay, so the power simply tells you to multiply the base how many times. Okay, how much the power has been, so much the power has been raised to. So now in mathematics, everything is built under rules. Okay, there are rules to follow in mathematics. So just look at some of the rules that we have to follow under this topic. Okay, so rules, write them in red. Rules of indices. Okay, rules of indices. Okay, so rule number 1. Okay, rule number 1. So under this rule, whenever you have a base, okay, this is a base, a bigger number, a base raised to the power 0. Okay, so in this case, okay, in this case we can see that the power is 0. Okay, the power is equal to 0. Okay, so when the power is equal to 0, your answer will be 1 always. Okay, when the power is ever equal to 0, your answer will always be 1. Okay, so this rule states that any number raised to the power 0, any number raised to the power 0 is 1. Any number or anything, it could be a number or a letter, raised to the power 0 will give you 1. So for example, okay, 4 to the power 0 this is automatically 1, okay? Or x to the power 0, this is automatically 1. Or y to the power 0, this is automatically 1 by the rule, okay? According to the what? According to the rule, okay? Then the second rule, okay? The second rule, which is rule number 2. Rule number 2 states that, let's say you've been given the base raised to the power 1, okay? So whenever the base has been raised to the power 1, the answer will be the base itself, okay? The answer will be the base itself, okay? For instance, if you have 3 raised to the power 1, the answer will be what? The base, which is 3. Okay, if you have 4 raised to the power 1, the answer will be 4. 5 raised to the power 1, the answer will be 5. Okay, so according to this rule, we can say that any number raised to the power 1 is that number. Okay, so this does not only apply to numbers, okay, even variables, okay, what we call letters. So similarly, x raised to the power 1 is x. Y raised to the power 1 is y. Okay, so that is this rule. Very simple, very, very simple. Okay, so now let's look at another rule under indices. This is rule number 3. Okay, so according to this rule, we are going to call it multiplication. It's under multiplication. Okay, under multiplication. Now, according to this rule, let's say you have, okay, same bases, right, being multiplied, okay, same bases, right? So you have the base A raised to the power m times the base A raised to the power n, okay? So this one, listen carefully. So when you notice that you have the same bases, okay, what you do here, you get the base and add the powers, m plus n, okay? Whenever you're multiplying bases that have got the same, you're multiplying the same bases, add the powers, okay? Add the powers. So for instance, e.g., you have 5 raised to the power 2 multiplied by 5 raised to the power 1. What is this going to be? Okay, so you notice here, the first thing, before going anywhere, you notice the same bases. Okay, you have 5 and 5, okay, same bases. So you get the base, add the powers, 2 plus 1, and this will be 5. 2 plus 1 is what? 3. Okay, now do you just end here? No. So this 3, what is it telling you? It tells you that multiply 5 by itself 3 times. So this will be 5 by 5 by 5. Okay, and then you multiply 5 by 5. This is 25. Okay, you bring here this one, 25 by 5. This will give us 125, and of course that's our answer. Okay, but there is our answer. So powers of the same base, okay, powers of the same base, you add them, okay, add the powers if the base is the same, okay. add the powers if the base is the same. Okay, look at another rule and multiplication. Okay, let's look at another example under multiplication. In this case, okay, you have another example. Okay, so in this example you are given 6 to the power 1 multiplied by 6 to the power 0. Okay, so you notice here, first thing is multiplication, the bases are the same, so this is going to be 6, add the powers 1 plus 0, this is going to be 6, 1 plus 0, that is 1, 6 raised to the power 1, what did we say? Okay, according to this rule here, anything raised to the power 1 is that number itself. Right? So 6 raised to the power 1, it is automatically 6. Okay, imagine you're given x raised to the power 2 multiplied by, okay, let me write this like this, x raised to the power 2 multiplied by x raised to the power 3. The bases are equally the same, so this will give us x. Add the powers, 2 plus 3. This will become x. 2 plus 3, that is 5. Okay, you can't simplify this any further because we haven't been given the value for x. Okay, next rule. Okay, rule number 4, division. Division of same bases. The division of same bases here, if you are dividing a raised to the power m over a raised to the power n, what do? Okay, you get the base, then you subtract the powers. As simple as that. Same bases, get the base and subtract the powers. Okay, example. Okay, this example, you have 2 raised to the power 3 over 2 raised to the power 1. Okay, so to answer this example, according to this formula, the bases are the same, so you're going to get the base, then the powers you subtract them, 3 minus 1, and this will give you 2. Subtract here, you get 2. Okay, then this 2, what does it tell us? It tells us to multiply 2 how many times? 2. Okay, multiply 2 times, and here you simply get 4. Get 4 there. Okay, this is very simple, straightforward. Just follow the rules. Okay, the most important thing here is to follow the rules. Okay, then you have another rule now, rule number 5. So now this rule, when you are given a base, okay, raised to a power m, then in brackets you have another power. How do you handle such? Okay, so this one, you get the base and then you multiply the powers. Okay, multiply the powers. So e.g., you have 6 raised to the power 2 in brackets, then you have another power 2. Okay, another power 2. So what does this mean? Get your 6 here, then the powers, multiply them. That's what it means. So this is going to be 6. When you multiply the powers, you get 4. Now, what does this 4 tell you? It tells you to multiply 6 by itself how many times? 4 times. 6 by 6 by 6 by 6. Okay, 6 by 6, you get 36 here. Okay, then you multiply 36 by 6. Okay, and whatever you get, you multiply it by 6. Okay, and that will be your answer. Okay, that will be your answer. So here, whenever you've been given a base with a power and put in a brackets another power, this becomes a m times n, and this is what we've just illustrated. Okay, that is what we have illustrated. And two more rules before we can, so two more rules. So now here, let's say you have different bases. Okay, for example, you have a b. These are bases, and they are put like this, raised to the power n. Okay, so this will become a will have its own base operational, so n times b n. Okay, so this is what it will be. Okay, let's say you have p q raised to the power n. This will be p, you get the power, times q, you get the power. Okay, get the power. Okay, so that's what this rule states. Okay, that is what this rule states. Okay, so in other words, if you have got 3x raised to the power 2, how do you work out such a thing? Okay, how do you work out such a thing? So this 3 will apply, this power 2 will apply to the 3, then you say multiply, then the x, the same power. Okay, that's how you work this out. Okay, then you can finish it off. 3 squared, we now know this is same as 3 by 3. Okay, so times x squared, this is same as x by x. 3 by 3, that is 9, times x by x, we go back to x squared, and the answer is 9x squared. Okay, 9x squared. So this power here applies to both the numbers inside the brackets. Okay, let's try it again one more time. So you've been given 2y raised to the power 3. How would this be? This will simply be 2. I said the power applies to both numbers, so 3 multiplied by y to the power 3. You can simplify this. 2 to the power 3. This 3 tells you multiply 2 3 times. You get what? 8. That is y3, y3. So 8 y to the power 3. And this one will end just here. Okay, so another rule, similar rule. Okay, similar rule. If you've got that is rule number what now? It's rule number 7 now. Okay, so this rule, you've got a over b raised to the power m. Okay, what does this imply? This simply means this power will also apply to both numbers in the brackets. So this is going to be a to the power m over b to the power what? M. Okay, let's look at it in terms of numbers. Okay, so let's say you've been given 1, okay, over 2, and these are raised to the power 2. Okay, these are raised to the power 2. So I said this power applies to both numbers. So you're going to write 1 to the power 2 over 2 to the power 2. Okay, then you simply work it out. So here again, another rule. Whenever 1 is raised to something, it will always give you 1. Okay, so 1 raised to 9, this is 1. Okay, 1 raised to 0, this is 1. 1 raised to 4, this is still 1. Okay, so 1 raised to anything, it will still give you 1. So 2 raised to the power 2, that is 4, and this is where it ends. Okay, that is where it ends. So now these are the rules that we've looked at in this this video. Okay, I hope you've been able to understand and you are able to apply these rules. Okay, so the other rule is where now you've been given. So the other rule is where you've been given the base, but then the power is a fraction. Okay, the power is a fraction. Okay, so you've been given the base. We said this is the base, but then the power is a fraction. Okay, so now how do we handle such type of a question? How do we handle such type of a question? Okay, so now you have a raised to the power m over n. Okay, so this would be, okay, this will change into this form. Okay, we're going to introduce a square root. Okay, then the base goes inside the square root. Okay, then this m, okay, this m, you're going to introduce brackets. So the n comes here, and the m comes here. Okay, so this is actually the formula whenever you've been given what, a base that has got a fraction as a power. So now let's say you have 27 raised to the power 2 over 3. Okay, so we know that the base it is 27, and this is our power. So this, we're saying we're going to introduce a square root. The base goes inside the square root, then this 3 which is down comes here, and then you open brackets, and the 2 comes outside the brackets like that. Okay, then this you can simply work out. Okay, this you can simply work it out. Okay, so now we have the cube root. Okay, we have what we call a cube root. So the cube root, this is where you have a square root with a 3 here. We call this the cube root. Okay, then apart from the cube root, you have a square root. The square root is just this sign. Okay, it's just this. So what does this 3 mean here? Okay, what does this 3 mean here? Okay, so what that 3 means is that whatever number is in here, okay, whatever number is in here, okay, whatever number is in here, let's say the number that is in here is 8. So this 3 tells you that, okay, look for a number. Look for a number. So the 3 tells us that look for a number that can go into 3, not really go into 3, or look for a number such that when you multiply that number 3 times, okay, okay, look for a number such that, okay, so this 3 tells us look for a number, okay, look for a number that, okay, look for a number that you will multiply by itself 3 times to get 8. Okay, so when we say find the cube root of 8, what we want is a number that will multiply it by itself 3 times to get 8. Okay, so we can start with maybe 1 by 1 by 1. So like this, 1 by 1 by 1. 1 times 1 is 1 times 1 it is 1. Let's try 2. 2 by 2 by 2. Okay. 2 by 2, this is 4. 4 by 2, we get 8. So we have our 8 here, which is here. So this means that the cube root of 8 is simply 2. The cube root of 8 is simply what? 2. Okay. The cube root of 8 is simply 2. So now, here in this example, we are told the cube root of 27. So this 3 tells us, look for a number that you're going to multiply by itself 3 times to get 27. Okay. So we can start with 1. 1 times 1 times 1, this is 1. 2 by 2 by 2, we've just solved this. This is 8. Let's go to 3 by 3 by 3. 3 by 3, this is 9. 9 times 3, you get 27. And we've gotten our 27, which is here. Okay. So meaning the cube root of 27 is basically what? 3. But remember, we have got a 2 outside here. So this 2, what does it tell us? 3 by 3. And 3 by 3 gives us 9. Okay. Sorry, this seems to be a lot, but if you would practice it, it's all simple and straightforward. Okay, so long as you just follow the rules, follow all the steps. Okay, everything will be okay. Okay, and now let's look at the last row. Now this row here is whereby you have a base raised to a negative power. Okay, a base raised to the negative power. So this, what you do to get rid of the negative, you're going to put 1. Okay, and then you say over this, but without the negative. So the 1 has gotten rid of the negative. Okay, the 1 has gotten rid of the negative. Let's try to show it in terms of numbers. Okay, so let's say you've got 3 to the power negative what? 2. So to get rid of the negative, okay, this will simply be 1 over, then you write this, but without the negative, because the 1 on top has gotten rid of the negative. And this you can finish it off. 1 over, what is 3 squared? By now we know 3 squared is the same as 3 by 3, which is 9. And this is your answer. Okay, so anything raised to the power negative, okay, it is simply 1. Okay, so now let's try to change up things. Okay, you see something. So let's say you have 8, okay, raised to the power negative 2 over 3. Okay, so here there are 2 things that to apply. Okay, one, you notice that the power is negative. The power is negative. Second, power is a fraction. So these are exam type of questions. These are exam type of questions. So we have 2 things that we notice. The power is a negative and it is also a fraction. Okay, so first thing to do, you get rid of the negative power. So this is going to be, you introduce 1. Always when getting rid of the negative, introduce 1, then write everything but without the negative. Okay, so this is going to be 2 over 3. Okay, now when it is like this, okay, you're going to write it like 1 over, so this again, you remember, a raised to the power m over n. This became what? The base goes inside the square root, then the denominator comes here, the numerator there. Okay, so that's what we are going to apply for this. Okay, so our base is 8, so I'm going to say square root. Our base is 8 and denominator is 3, then raised to the power 2. Okay, so we are just following our rules and our steps. There's nothing confusing here. So we're going to write 1 here over, what is the cube root of 8? So when finding the cube root, always start 1. Okay, so 3 multiply, let's say 1 by 3, 1 3 times 1 times 1 times 1, this is 1. Go to 2, 2 by 2 by 2, 2 by 2, that is 4, 4 by 2, you get 8, and we have our 8 here. So meaning a number that we can multiply by itself 3 times to get 8, it's 2. Okay, so the cube root of 8 is what? 2. Remember, we still have a 2 there outside. Okay, so this will become 1 over 2 to the power 2, that is 4. Okay, and this here is your answer. Okay, so this is your answer. So these are exam type of questions where they are going to combine maybe 2 or 3 rules under one question.